In 1906, a 14-year-old boy named Thomas Wirtz walked into the Weyerhaeuser Mill in Potlatch, Idaho for his first day of work. His job was simple: stand beside the head saw, watch for kickbacks. If a board came loose from the carriage, he was supposed to shout a warning. He lasted 43 minutes. The saw hit a hidden nail buried deep in a white pine log. The blade shattered. A fragment the size of a dinner plate spun across the mill floor at 400 feet per second and struck Thomas Wirtz in the chest. He was dead before his body hit the sawdust. His father, who worked the green chain at the same mill, found out when the lunch whistle blew and his son didn't come to eat. That Weyerhaeuser mill processed over 1 million board feet of lumber every single day. It ran 22 hours out of 24, stopping only for maintenance and to drag out the bodies. In the year Thomas Wirtz died, that one facility employed 400 men and lost 19 of them to accidents. Crushed by logs, pulled into saws, scalded by steam, buried under lumber avalanches, and yet the mill never stopped running. It couldn't afford to. America was building itself board by board, and the sawmills were the beating heart of that construction. Every farmhouse on the Great Plains, every railroad tie stretching toward the Pacific, every mine shaft dropping into Montana copper country, all of it started with lumber. And all of that lumber passed through mills like this one. This is the story of how America built sawmills that could cut more wood in a single day than 1,000 men could cut by hand in a year. It's a story of engineering genius and industrial ambition, but it's also a story written in blood and sawdust. Bila, because the men who fed those machines paid for every board foot with something that can never be measured in dollars. Let's go back to the beginning. Before the machines, there were pit sawyers. And if you want to understand why steam sawmills changed everything, you need to understand what those men endured. Picture this. 2 men standing over a log suspended above a pit dug into the earth. One man stands on top of the log. He's called the top sawyer. The other man stands in the pit below. Eye looking up, he's the pit man. Between them runs a single saw blade, 7 feet long, with handles at both ends. The top sawyer pulls up. The pit man pulls down, back and forth, hour after hour, cutting a single line through a log that might take 2 full days to section into boards. The pit man got the worst of it. Every stroke of that saw sent a stream of sawdust directly into his face, into his eyes, into his mouth and nose. He breathed wood dust all day, every day, until his lungs gave out or his eyes went bad. Pit sawyers rarely live past 50. Most went blind before that, and for all their suffering, 2 skilled pit sawyers working together could produce maybe 200 board feet of lumber in a 10-hour day. That's enough wood to build about 1/10 of a modest farmhouse. When colonial America needed lumber, those pit sawyers were all they had. Every plank in every ship, every beam in every barn, every board in every church. And all of it came from men standing in holes, pulling saws, breathing dust. The first water-powered sawmills arrived in America in the 1630s. The technology was simple. Take a saw blade, attach it to a wooden frame, connect that frame to a water wheel with a crank mechanism. Let the river do the work. These early mills were crude, but they represented a fundamental break with everything that came before. For the first time, the energy required to cut wood didn't have to come from human muscle. A single water-powered mill with 1 blade could produce 400 board feet per day, double what the pit sawyers could manage. And the mill didn't get tired, didn't go blind, didn't need rest. The problem was location. You could only build a water-powered mill where you had a river with sufficient drop to turn a wheel. That meant hauling logs to the mill, sometimes from miles away, and it meant entire regions without good water power simply couldn't have mills at all. By 1800, when America had over 1,000 water-powered sawmills scattered across the Northeast, but the country's hunger for lumber was growing faster than those mills could feed it. The population doubled between 1800 and 1830, doubled again by 1860. Every new American needed shelter, needed furniture, needed fences and barns and wagons and coffins. The forests seemed endless, but the mills that could turn those forests into lumber were bottlenecked by geography and technology. Then came steam. The first steam-powered sawmill in America started operation in New Orleans in 1803. It was a primitive thing, unreliable and expensive to run, but it proved a principle that would reshape the continent. You didn't need a river anymore. You didn't need a waterfall. All you needed was fuel, water for the boiler, and logs to cut. Within 20 years, steam sawmills began appearing throughout the Mississippi Valley. They were portable, in a way watermills never could be. Build your mill near the forest, cut until the timber was gone, disassemble the boiler and engine, move to the next stand of trees. The forest came to watermills. Steam mills could go to the forest. The early steam mills still use the same basic sawing technology as their water-powered predecessors. A single blade moving up and down in a reciprocating motion. The sash saw, they called it. Picture a butter knife moving through a loaf of bread. Slow, steady, one stroke at a time. Where a good sash saw could cut maybe 3,000 board feet in a 12-hour day. Impressive compared to pit sawyers, but nothing compared to what was coming. In 1814, a man named Benjamin Cummins took out a patent on something that would change everything: the circular saw. Instead of moving up and down, Cummins' saw spun continuously, a steel disc with teeth around its edge, rotating at speeds that made the reciprocating sash saw look like an antique. The first circular saws were small, maybe 12 inches in diameter, good for shingles and light cutting. But the principle was sound. By the 1850s, millwrights were building circular saws 6 feet across, then 7, then 8. A single circular saw blade spinning at 500 revolutions per minute could cut through a 30-inch log like it was warm butter. No more waiting for the blade to return to starting position. No more lost motion. Just continuous, relentless cutting. The numbers tell the story. A water-powered sash saw produced 3,000 board feet per day. A steam-powered circular saw could produce 50,000. And that's not an improvement. That's a revolution. But the circular saw had a problem, and understanding that problem helps you grasp how these machines actually worked. When a circular saw spins, the teeth at the outer edge travel much faster than the teeth near the center. On a 6-foot blade, the outer teeth might be moving at 150 miles per hour. The teeth 6 inches from the center are moving at a fraction of that speed. This creates uneven cutting. Worse, it creates heat. And a hot saw blade warps. A warped blade wobbles. A wobbling blade binds in the cut. A binding blade shatters. The men who ran these mills learned to read their saws like doctors reading pulses. They listened to the pitch of the blade. A healthy saw sang at a consistent tone. A sick saw wavered. They watched for the slight shimmer that meant a blade was starting to dish, bowing outward from heat. They felt the vibration through the mill floor. An experienced sawyer could tell you within 5 minutes when his blade needed water, needed filing, or needed to be pulled off the mandrel and replaced. The head sawyer was the highest paid man in the mill, and for good reason. His judgment determined whether the operation ran smoothly or whether men died. A blade that shattered under load threw fragments in every direction. A blade that bound at speed could kick an entire log backward off the carriage with force enough to kill everyone in its path. These men earned their money. The circular saw dominated American mills through the 1870s and 1880s. But it had a fundamental limitation: kerf. That's the width of the cut, the wood that gets turned into sawdust instead of lumber. A circular saw blade needs to be thick enough to resist the stress of spinning at high speed. That thickness means waste. A typical circular saw blade had a kerf of 3/8 of an inch. For every 1,000 board feet of lumber you produced, you lost maybe 200 board feet to sawdust. In a country cutting billions of board feet annually, that waste added up to entire forests. The solution came from California. In the 1880s, Sawmillwrights in the Big Sierra Nevada operations began experimenting with a different design. The bandsaw. Picture a ribbon of steel, maybe 30 feet long, welded into a continuous loop. Mount that loop on 2 massive wheels, one above the cutting zone, one below. Spin the wheels. The ribbon of steel becomes a moving blade that cuts continuously, like a circular saw, but with one critical advantage. A bandsaw blade can be thin. Really thin. 1/8 of an inch? 1/16. On some of the finest bandsaws ran blades just 1/32 of an inch thick. That narrow kerf meant less waste. It also meant you could cut larger logs. A circular saw is limited by its diameter. You can't cut a log wider than the distance from the center of the blade to the saw collar. A 6-foot circular saw maxes out at logs maybe 30 inches across, but a bandsaw has no such limitation. The blade rides up and down on those wheels, and the space between the blade runs is limited only by the size of the wheels and the height of the guides. Bandsaws could process logs 6 feet in diameter, 8 feet. The massive old-growth Douglas fir of the Pacific Northwest, trees too large for any circular saw, fell before the bandsaw like grass before a scythe. By 1900, the bandsaw had conquered the lumber industry. The big mills of Washington and Oregon, the ones processing 1 million board feet per day, ran batteries of bandsaws working in sequence. A log entered the mill and passed through the first saw, which stripped off the outer slab. Then to the second saw, which cut the first board. Then the third, fourth, fifth. Each saw trimmed another piece until the log was reduced to a stack of lumber and a pile of slabs for the waste fire. These mills operated with a precision that would seem mechanical even today. The logs arrived on carriages running on steel rails. The carriage operator, called a setter, controlled the position of each log with hand levers that adjusted hydraulic rams. He could shift a 10-ton log a 1/16 of an inch with fingertip pressure. His job was to read each log, see where the best lumber hid inside the bark and sapwood, and set cuts that maximized the yield. A good setter was worth more than the machinery. The wood itself varied constantly. Grain patterns, hidden rot, old fire scars, embedded metal from nails or horseshoes or bullets. The setter had to make split-second decisions about every log. Turn it 15 degrees to avoid that spiral grain. Take an extra 1/2 inch on this cut because there's checking on the face. Reject this log entirely because something's wrong with its weight. It doesn't feel right. Feel. In a mill processing logs by the trainload, the final judgment often came down to how a log felt when the setter touched his controls. Those men had spent years beside the machinery, absorbing its rhythms, learning to read wood the way a sailor reads water. Their knowledge existed in their hands and their bones, not in any manual. Behind the head saws came the edgers. Rough-cut lumber from the head saw needed trimming. The edges were irregular, still carrying bark or the curved outer surface of the log. Edgers were smaller saws, circular or band, that squared the lumber to standard widths: a 6-inch board, an 8-inch board, a 10-inch board, and standard dimensions that builders across the country could rely on. The edger operators worked even faster than the head sawyers. Each piece of lumber came to them for just seconds. Judge the width, adjust the guides, push it through. Next piece. All day long, an endless stream of rough lumber demanding instant decisions. After the edgers came the trimmers. Rough lumber varied in length depending on the original log. Trimmers cut boards to standard lengths, 8 feet, 10 feet, 12 feet. On 16 feet, anything too short to make grade went to the waste pile. Anything warped or cracked or rotten followed it. The trimmer operators were quality control, the last line of judgment before lumber became a commodity. From the trimmers, lumber dropped onto the green chain. This was where the sorters worked, and their labor was purely physical. Boards came down a moving chain conveyor, sometimes hundreds per minute, and the sorters had to grab each one, read its grade in a glance, and throw it onto the appropriate pile. Douglas fir, number 1 clear here, number 2 common there. Utility grade in the back, rejection pile for firewood. Green chain work destroyed men's bodies. The lumber came wet and heavy, fresh from the saw. A 12-foot 2x12 of green Douglas fir weighs over 100 pounds. The sorters lifted and threw these boards all day, every day. Their backs went first, then their shoulders, then their hands, the joints swelling until they couldn't close their fists. A green chain worker at 40 was an old man. A green chain worker at 50 was crippled or dead. Behind the green chain came the yard, mountains of lumber stacked to dry. separated by thin stickers, slats of wood that allowed air to circulate between the boards. Lumber needed to dry before it could be sold. Green wood warps, shrinks, splits. The yard workers rotated stock constantly, moving older lumber to the front, or stacking fresh lumber in the back. Tens of millions of board feet arranged in rows that stretched for hundreds of yards. And beyond the yard, the shipping. Rail lines running directly into the mill. Boxcars waiting to be loaded. Teams of loaders rolling lumber into cars with iron hooks, stacking it tight for the journey to Portland, Seattle, San Francisco, Chicago, New York. Every board stamped with the mill's mark. Every shipment weighed and tallied. Every car sealed and tagged for delivery. This was the sawmill in its mature form, a machine that swallowed forests whole and spit out the raw material of civilization. Let me tell you about the scale these mills achieved, because the numbers border on the unbelievable. The Weyerhaeuser Mill B in Everett, Washington, could process 1.2 million board feet of lumber in a single 20-hour shift. That's enough wood to build 60 houses. Every day. The mill employed over 1,000 workers directly, or with another 3,000 in the logging camps that fed it. At its peak in 1913, this single facility consumed old-growth Douglas fir that had taken 500 years to grow and reduced it to lumber in less than 5 minutes per log. The Potlatch Mill in Idaho, the one where Thomas Wirtz died, wasn't even the largest in the region, but it ran continuously for nearly 50 years, on stopping only for major repairs and the annual spring shutdown when the log drives brought fresh timber down the rivers. In those 50 years, that single mill cut enough lumber to build a boardwalk 1 foot wide stretching from the earth to the moon. Think about that for a moment. One mill, one facility, enough lumber to bridge the distance between planets, and there were hundreds of mills like this one across the country. The steam that powered these operations came from boilers burning wood waste, bark stripped from incoming logs, slabs from the first cuts, sawdust collected beneath the saws, rejected lumber too damaged to sell. The mills were self-fueling systems. The trees they cut provided the energy to cut them. Nothing was wasted except the men. Those boilers deserve attention because they were the heart of the whole operation. A large sawmill boiler generated steam at 150 to 200 pounds per square inch of pressure. Picture a cylinder of riveted steel, 10 feet in diameter and 40 feet long, filled with water heated by fire until it became something barely containable. That steam drove pistons connected to crankshafts connected to line shafts running the length of the mill. Leather belts transferred power from those line shafts to individual machines. The saws, the carriages, the conveyors, the planing mills, on everything dancing to the rhythm of the steam engine's heartbeat. Boiler explosions killed more mill workers than saw accidents. When a boiler failed, it didn't leak or crack, it detonated. Rivets became bullets. Shrapnel spread across the mill in a hemisphere of destruction. The steam itself became a weapon, superheated gas that cooked men where they stood. 100 men might be working in a mill when its boiler exploded. 20 or 30 would die instantly. Another 10 or 20 would die in the hours that followed, scalded beyond any hope of survival. The firemen who fed those boilers worked in conditions that would be illegal in any modern workplace. Temperatures above 130 degrees, air thick with ash and steam, shifts running 12 hours, sometimes 14. The fire had to stay hot, the pressure had to stay up. The mill never stopped, so the firemen never stopped. They worked until they collapsed, were dragged outside to recover, and then returned to their stations. In the Pacific Northwest mills, most firemen were immigrants, Scandinavians, many of them, Finns and Swedes and Norwegians who had arrived in America looking for opportunity and found the boiler room instead. They died of heat stroke in summer. They died of pneumonia in winter, running from the inferno of the boiler room into the freezing rain of the Washington coast. They died when boilers exploded because they were always closest to the blast. Their names fill the cemetery records of towns like Everett and Tacoma and Longview, row upon row of wooden markers, most now rotted to nothing, recording men who came from countries with unpronounceable names to fuel the engines that built America. The sawyers themselves faced different dangers. The head saw was the most spectacular, but the edgers and trimmers claimed more lives. Those smaller saws spun faster. They were set closer together. The men who operated them worked in confined spaces surrounded by spinning steel on multiple sides. A moment's inattention, a slip on sawdust-slicked floor, and a man could lose a hand, an arm, his life. The term for getting pulled into a saw was being called, as in, Johnson got called yesterday, as in, the saw called him. Workers developed superstitions about the machines. They believed some saws were hungry, eager, waiting for victims. They named the worst saws the way sailors name storms. There was a bandsaw at the Simpson Mill in Shelton, Washington, that workers called the Widow Maker. It had killed 11 men by 1920. Men kept working these jobs. They had to. The mills paid better than farming or fishing. A head sawyer might earn $4 a day when a farmhand made one. A setter could earn $5. Even green chain workers made $2, enough to rent a room and eat 3 meals and maybe send money home to family. The company towns that grew around the big mills offered a kind of security, too. Housing provided by the company. A company store, a company doctor, schools for the children, churches for Sundays. Life structured around the mill whistle that blew at 6 in the morning and again at 6 at night. But that security came with strings. The company housing meant you could be evicted if you lost your job or complained about conditions. The company store extended credit that kept workers in debt. The company doctor worked for the company first and the patient second. Injuries that should have ended in compensation often ended in dismissal instead. Can't work? Can't stay. Unions tried to organize the mill workers throughout the late 1800s and early 1900s. The industrial workers of the world, the Wobblies, made the lumber industry a special target. They understood that the conditions in the mills were exploitative, that men were dying to make stockholders wealthy, that the system treated workers as expendable components in a machine designed to extract profit from the forest. The response from mill owners was brutal. Strikers were fired, blacklisted, beaten by company police, in some cases, killed. The Everett Massacre of 1916 saw 5 IWW members shot dead by deputies as they tried to land in Everett Harbor. The dead men had come to support striking mill workers. They were met with gunfire. None of this stopped the mills. The lumber had to flow. The trains had to stay loaded. The nation had to keep building. Let me tell you about one mill in particular, because its story captures everything about this era. The Clearwater Mill in Lewiston, Idaho, started operation in 1927 and ran for 60 years. It was built by Potlatch Lumber Company, later Potlatch Corporation, on a site chosen specifically for rail access and river adjacency. The Clearwater River provided water for the boilers and a highway for log drives. To the Northern Pacific Railroad provided shipping to markets across the country. At its peak, the Clearwater Mill employed over 800 workers and processed 400 million board feet of lumber annually. That's enough wood to build 20,000 houses every year, for 60 years. The mill ran 3 shifts, around the clock except for Sundays. The morning shift came in at 6, the swing shift at 2, the graveyard shift at 10. Each shift had its own character. The morning crew were family men, steady workers who wanted predictable hours. The swing shift drew younger workers, men who wanted their mornings free for fishing or drinking or sleep. The graveyard shift got everyone else, the desperate, the single, the damaged. Working the graveyard at Clearwater meant existing in a world of artificial light and unnatural rhythm. The mill ran the same by day or night, but human beings didn't. Mistakes happened more often in the small hours. Attention wandered, reaction slowed. The machines didn't care. They kept spinning, kept cutting, kept demanding human hands to feed them. The injury logs from Clearwater make for grim reading. October 1934, a man named Harold Gustafson lost 3 fingers to an edger saw. January 1938, a man named Peter Kowalski was struck by a falling timber in the yard and spent 4 months in the hospital with a broken back. August 1947, a man named James Whitehorse was pulled into a conveyor belt and strangled before anyone could cut the power. He was 19 years old. These weren't rare events. They were regular occurrences documented in leather-bound ledgers that survive to this day in the company archives. The ledgers record injuries with clinical precision. Date, name, nature of injury, disposition, lost time. That last column, lost time, measures the only thing that mattered to the company. How long would this worker be unable to work? A finger costs 3 weeks. An arm costs forever. A life costs nothing because the dead don't file claims. The men who survived the Clearwater Mill carried it with them forever. Listen to their oral histories, recorded by historians in the 1980s and 1990s, and you hear the same themes again and again. Pride in the work, pride in the skill, pride in their ability to run those machines and come home alive. But underneath the pride, something else. A weariness, a knowledge of what the work had cost, friends lost, health broken, years spent in a cathedral of noise and danger while the lumber piled up and the company got rich. One man, interviewed in 1989, put it this way. He said, "I gave that mill 40 years and my good arm. They gave me a pension and a pat on the head. I figure we're about even." He'd lost his right arm to a bandsaw in 1961, kept working with one arm for another 20 years. Had no choice, no other skills, and no other place to go. The mill was all he knew. The technology in those mills kept advancing, even as the human cost remained constant. By the 1940s and 1950s, electric power began replacing steam. The old boiler rooms fell silent. The firemen found other work or died. Electric motors were cleaner, more efficient, easier to maintain. They could be placed directly on individual machines instead of requiring the complex system of line shafts and belts that had defined the steam era. The change transformed the sound of the mills. Steam engines have a rhythm, a pulse, the hiss of escaping vapor, the thump of pistons, the endless heartbeat of metal on metal. Electric motors hum, they whine, they speak in frequencies that don't register as sound so much as vibration. Workers who'd spent decades in steam-powered mills found the electric facilities eerily quiet. Too quiet. You couldn't hear danger coming the same way. But the saws kept spinning, the logs kept flowing, the lumber kept stacking, and men kept dying. Automation arrived slowly. The first computerized systems appeared in the 1960s, controlling lumber grading and sort systems. By the 1980s, lasers were reading logs, calculating optimal cutting patterns, directing carriages with precision no human setter could match. The head sawyer didn't disappear, but his role changed, from decision maker to machine monitor, from craftsman to supervisor. Some old-timers welcomed the changes. On anything that kept men away from the machines reduced the injury rate. The most dangerous jobs, the ones closest to the saws, could be done remotely now. Televisions showed the cutting zone. Joysticks replaced hand levers. A man could set logs from a climate-controlled booth 30 feet from the head saw. Other old-timers mourned what was lost. The skill of reading wood by touch, the art of listening to a saw's song, the connection between worker and material that defined craftsmanship. These things couldn't be programmed. They existed in human bodies, human nervous systems, and they died when those bodies were removed from the mill floor. The modern sawmill is a different creature than its predecessors. Walk into a contemporary mill and you'll see machines doing work that once required hundreds of men. A log enters the mill on a conveyor. Sensors measure its dimensions. Computers calculate optimal cuts. Robotic arms position the log on the carriage. The saws fire in sequence, each one making cuts programmed to the millimeter. The lumber that emerges drops onto automated sorting systems that read grade and dimension without human intervention. A handful of technicians monitor screens while the mill processes more wood in a day than those old steam operations could manage in a week. The green chain is gone. The sorters are gone. The carriages run themselves. The edgers adjust automatically. The lumber moves from saw to stack to truck without a single human hand touching it. Safer? Without question. A modern mill processes millions of board feet with injury rates a fraction of what they were in the steam era. The machines that killed Thomas Wirtz and Harold Gustafson and James Whitehorse have been tamed, encased in guards, controlled by sensors that stop everything if a human enters the danger zone. But something has been lost too. The modern mill employs perhaps 100 workers where the old mills employed 1,000. The company towns have dried up and blown away, the unions have faded. The culture that built itself around the lumber industry, that particular blend of danger and skill and community, exists now only in memory. I've talked to the sons and grandsons of sawmill workers, men who grew up hearing stories about the old days. They speak of their fathers with a mixture of admiration and horror. Admiration for the toughness, the resilience, the ability to face those machines day after day and keep coming back. Horror at the costs paid in flesh and blood and shortened lives. One man told me his grandfather had died at 62. Lung disease. The sawdust had gotten him. His grandfather had worked in mills from age 14, first as a cleanup boy, then as a tail sawyer, finally as a head sawyer running a bandsaw at the Simpson Mill. Nearly 50 years breathing the air in those facilities. The dust accumulated in his lungs until they could no longer function. This man, the grandson, had gone to college, become an engineer. He designs automation systems for modern mills, the very systems that have made his grandfather's job obsolete. He says he feels the irony every day, that his education and career were paid for by his grandfather's suffering, that the machines he designs are monuments to men who died making lumber the hard way. Someone had to do it, he told me. Someone had to cut the wood that built this country. Those men volunteered. They showed up every day knowing the risks. I can't honor that sacrifice by pretending it didn't happen. All I can do is make sure no one has to die that way again. The numbers are staggering when you step back and look at them clearly. Between 1880 and 1980, the American lumber industry employed tens of millions of workers across logging, milling, and processing operations. Conservative estimates place the death toll in the hundreds of thousands, injuries requiring hospitalization number in the millions. Every major mill town has its cemetery filled with markers for men who died too young. And for all that suffering, what was produced? The houses we live in, the offices we work in, the schools where our children learn, the churches where we marry and bury, the railroad ties that connected a continent, the ships that sailed from Atlantic to Pacific, the furniture we sit on, the books we read, the instruments we play, the pencils we write with, the paper those pencils mark. Everything touched by wood was touched by those mills, and everything touched by those mills was touched by the men who ran them. The steam sawmills that processed 1 million board feet daily didn't just make lumber. They made modernity possible. They converted standing forests into the raw material of civilization at a pace that no previous generation could have imagined. They did it through mechanical innovation, yes, but they did it primarily through the labor of men who gave their bodies to the machines. There's a memorial in Forks, Washington on the Olympic Peninsula, a bronze statue of a sawmill worker, his hands wrapped around an iron hook, his face set in the expression of concentration that defined these men's working lives. At the base of the statue, a plaque lists names, hundreds of names, workers who died in the mills and logging camps of Clallam County over 100 years of industrial forestry. Most tourists walk past without stopping. The statue is weathered now, green with oxidation. The names on the plaque are hard to read. The story they tell has been mostly forgotten. But those names matter. Those men matter. The Thomas Wirtzes and Harold Gustafsons and James Whitehorses of the lumber industry built something with their suffering. They built the material foundation of American life. Every board that passed through their hands became part of something larger. A house, a school, a church, a coffin. The mills ran because men fed them. The mills stopped running because technology made those men unnecessary. Somewhere between those two facts lies a truth about industrial progress that we rarely acknowledge. The machines that free us from danger also free us from meaning. The automation that saves lives also severs the connection between work and worth. The modern mill worker monitoring screens in a control booth is safer than his grandfather on the green chain. But he's also disconnected from the material in ways his grandfather never was. He doesn't feel the weight of green lumber, doesn't read the grain with his eyes and hands, doesn't earn his wages in sweat and blood. Is that better? Probably, almost certainly. The deaths and injuries and shortened lives of the steam era were too high a price to pay for any product. No board of lumber is worth a human life, but in making the work safe, we've also made it invisible. The men who run modern mills are anonymous in ways their predecessors never were. Their work doesn't leave marks on their bodies. It doesn't shorten their lives. It doesn't build communities around shared danger and shared triumph. The old sawmill workers knew each other, depended on each other, watched out for each other in ways that their working conditions demanded. The man at the head saw trusted the setter to position logs correctly. The setter trusted the carriage operator to advance smoothly. Everyone trusted the fireman to keep pressure steady. A failure at any point could kill men hundreds of feet away. Thus, that interdependence created bonds that don't form in a control booth. The last of those steam era workers are dying now. Men in their 90s who remember when the mills smelled like pitch and steam and blood, who remember the sound of a saw hitting metal buried in a log, who remember the faces of friends who got called by the machines and never came home. Their memories are being recorded, preserved in oral history archives. Their photographs are being digitized. Their tools are being displayed in museums. But the lived experience of working those mills, the knowledge that lived in their bodies, dies with them. In another generation, no one alive will remember what it felt like to stand beside a spinning bandsaw and feed logs into its teeth. No one will remember the heat of the boiler room, or the weight of green lumber, or the sound the mill made when everything was running right. That world will exist only in archives, in statistics. In the lumber that still stands in old houses, slowly becoming antique. The mills that could cut more wood than 1,000 men weren't just machines. They were ecosystems. Human ecosystems where men lived and worked and died in service of an industry that built a nation. Understanding those mills means understanding the people who ran them, their skills, their sacrifices, their suffering, their pride. 1 million board feet per day. A number that seems abstract until you realize what it meant in human terms. How many hands touched each log? How many eyes watched each cut? How many lives were risked each shift? How many families waited each night for men who might not come home? The great steam sawmills are gone now. The last of them closed in the 1970s and 1980s, replaced by electric facilities running automated systems. The buildings have been torn down. The machinery has been scrapped. The company towns have been converted to residential suburbs or simply abandoned, but the lumber remains in old houses, in antique furniture, in the bones of buildings that have stood for a century. Pick up a piece of heart pine from a demolished farmhouse. Look at the growth rings, count the years. That tree stood for 200 years before it met a sawmill. A man cut it down, another man loaded it onto a rail car, another man fed it through a saw. His hands touched this wood. His sweat soaked into this grain. The steam sawmills that never stopped running for 50 years built more than lumber. They built the physical infrastructure of American life. They built wealth for the men who owned them and poverty for many of the men who worked them. They built communities that have since dispersed and memories that are fading with each passing year. Most of all, they built a legacy of human endurance that deserves to be remembered. The next time you walk into a house, the next time you sit in a wooden chair, the next time you open a book or look at a wooden floor or lean against a fence post, remember the mills, remember the saws, remember the boilers and the carriages and the green chains and the yards. Remember the men who ran those machines, the setters and sawyers and sorters and firemen, the 14-year-old boys who died on their first day, the 60-year-old men who died of dust-filled lungs. The countless workers whose names fill cemetery ledgers across the lumber country. Remember them. They built this.